Welcome back to week 1 of our Chem 330 course, and we talked about how to write a straight chain, unbranched. Okay, this is important because that's what is going to lead us to the next set of conversation on this. Okay, unbranched straight chain. Okay, all right. What does that mean? Means there's a concept called isomers. Okay, isomers. Okay, in particular we're talking about what are called structural isomers. Okay, okay, what are structural isomers? They have same formulae. The compounds have same formulae, okay, but different way of arranging them. Okay, different way of arrangement. Okay, all right. So let's take this one compound that we haven't tackled, which is C5H12. Okay, if you want, you can pause the video, go ahead and write the structure in the condensed form, and then not like the one where it's spread out, but remember I showed you how to write the condensed form. Go ahead and do it for this, because I purposefully did not do it in the earlier one because I wanted to bring that here, because we've already established the open unbranched straight chain for C5H12. So go ahead and write the condensed version of it, and then continue watching the video to see if you got it right. All right, so if you have done everything right, this is what you should have. Right, this is exactly what you should see on your screen. That is C5H12. Right, now this is the straight chain, means all carbons are in one long chain. Okay, this is the fundamental, or you could call it the mother structure of the compounds that would probably be isomers of C5H12. Okay, to create isomers, all you got to do is cut the chain, don't make it 5. Okay, this is the fundamental chain. Okay, means everything is in straight chain. Now instead of, if I have to make isomers for C5H12, first I already established what my straight chain is. Instead of writing it 5, I'm going to write just 4 and then go vertically. Start putting carbons vertically. If you start putting it horizontally, you're going to end up with the fundamental again. So I'm going to put my carbon here. Okay, now this is completely different. This may have the same number of carbons and hydrogens, but they don't exactly have the same properties. Okay, which is also something. Now keep in mind, every carbon that's on the outer side will have 3. This carbon has 1 bond, so it will have 3 more, right? So it will have 3 hydrogens, right? This carbon has 2 bonds already, so it will have 2 more hydrogens. This carbon has, don't think of this as an external carbon. This is sandwiched between 3 carbons. It already has 3 carbons, so this can only have 1 hydrogen. The reason I'm writing particularly this, because it has a meaning. All right, this carbon again has 3, only a single bond, so it can have 3 more hydrogens. This can also have 3 more hydrogens. This is one isomer. Okay, let's think of, this is the first, this is the second. Okay, let's think of what most of you would probably do is take 3, okay, and put it here. Well, this is same as this, except you're starting from this side now. Okay, so these two are same and they don't count as a separate isomer. Let me repeat, just because you moved it 1, well, you still have 4, and you started from this side. If you had started from this side, that would be here. So these two are exactly the same. Okay, so I am going to say CH3. I'm not going to count that as a extra isomer. It is just primarily that it only has these two are identical, so that would still be 2. Okay, they're identical. I mean, we will probably have a classroom discussion on this, but I'm telling you now, as I'm teaching, that's what that is. All right, now we got 2. Let's do one more, but I'm going to pick a different color because it is starting to get a little bit crowded here with black. Okay, maybe even a blue might work. All right, so instead of doing 4, let's cut the chain down to 3. Now, if you start putting vertically here and here, that is same as one of these. Okay, if I put 1 here, because we have 5 carbon, if I put 1 here, it is just the same with the second, except this time you're just looking at it like an L, and that does not automatically make it a isomer. Okay, so this is not an isomer. So let's do 3, but this time instead of putting it one next to each other, it just, you should know how to put things in place. What if you put it this way? Okay, you will run out of options very quickly. Okay, there's no, it's like an airport exit. Okay, when you get off the plane, there is no way you're even going into any other area besides the area they tell you to go. Okay, I mean, even if you don't know airport signs, you still can't go back into where you're not supposed to. All right, so because it's already guided. Just like that, you will not get lost. Maybe you feel like you're getting lost, but you really are not, because you do have to be cognizant of, does anything I've created looks like already exactly like something I already have? Well, in that case, that is not an isomer. This right here is not an isomer because we don't have anything like this, because this only has 3 carbons and 2 carbons are on the same exact carbon. We don't have anything where we have 2 carbons on the same single carbon. No, this is not exactly like this, right? Right? This is not exactly like this. This is 2 carbons attached to a single carbon, and then the other 2 carbons are also attached to the same carbon. This might sound like this is the same, but it's not, because these 2 carbons right here are one attached to the other, and they are collectively attached to the carbon. All right, so this is a isomer. So now this carbon has 1 bond, so you can have 3 more bonds, so that where the 3 hydrogens will go. And as we get going in the course, you'll see I will not provide as much explanation as I did for that same particular property earlier. So that is 3. So far we have conclusively established that, well, when I said that these 2 are not isomers, I was right, because for a compound containing carbon and hydrogen, yes, this is true, but you will quickly realize down the road, when we add a third element that is not carbon or hydrogen, they may not be isomers. Okay, but I think we're a little bit too early in the game. So let me show you something of a list. Okay, so our carbon had what, 5 carbons, right? So I'm gonna post this. There is really no way to figure out how many isomers for alkanes. It's not that easy. I'm gonna post this particular sequence here. If you have a carbon that is 5, if a compound contains 5 carbons and the remainders is all just hydrogens, we will have 3 possible structural isomers. And didn't we establish that right here? 3 isomers, 1, 2, 3. These don't count as 2 separate things because they both have 2. So there is really no way for us to just, tell, okay, we remember how we had that formula, CnH2n plus 2. It's not like we don't have a specific formula to figure out how many structural isomers for alkanes. It's not that straightforward. So what I'm going to do is I'm going to have you create, I only briefly showed those screen, so it's already captured in my video. So you can always go back and look at, if I have so many carbons, how many structural isomers I have. All right, so so if I were to redraw what I did for my C5H12, okay, let me recapture it. So these are the structures I had: CH3, CH2, 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 CH3. This is your parent, because your parent would always have complete straight chain, and your isomers usually have branched chain, because we always have to start from the parent and then proceed to have branched isomers. So this is what I created, are the three structures we were able to establish based on, I'm only writing the condensed structures. You should quickly learn to write how to write condensed structures, because there's no way in the world you're going to be able to create open structures like that for a really complex molecule. Okay, that will take forever of your time. All right, so these are the three isomers we have established. Right now, these are branched. You see, well, what is a branch? Well, if a tree trunk is your fundamental, any branch that's coming off of that tree trunk is a branch. That's why they're called branches. So these are branched, right? Okay, now of the two, which one do you think is more branched? Obviously this is less branched. Of the two, this is more branched. Okay, keep this in mind, because we are going to talk about boiling point and melting point. Again, this is not as straightforward as like general chemistry concepts are, but I will try my best to get my point across. So boiling point and melting point. Okay, these concepts require you to have an understanding of straight chain versus branched. That branching and how much it's branched, and as a lot of meaning behind melting and boiling point concepts. Okay, if you don't understand how to do this, so as a drive home message, what I'm going to have you create is, I'm going to have you create, first figure out how many carbon is for this, how many hydrogen is for this compound. Since we've already established, and I don't think we did this, so go ahead and find the number of hydrogens for these, and then we've already established this one is 16, so I don't want to redo it. What I want you to do is A, B, C. For A and B, figure out how many hydrogens there is. Once you figure out, write me a straight chain parent or fundamental compound for each of this, and then write the isomers for each one of those. Okay, if you don't think there is an isomer possible, then say no isomers possible. Okay, if no isomers possible, okay, say no isomers possible. Okay, now that little screen I showed you has been captured, so you should have it. If not, I will post the link under the course description. So let's see if we can do this far. Okay, then, because we have a lot of things to do, like naming an alkane compound, and then looking at properties such as melting point, boiling point, etc. And then we got to do this for alkenes and alkynes as well. All right, so this is the initial set of videos I would like to post and have you fondle with it and see if you can get it right. All right, so I'm going to stop here, and in the answer I will post the correct answer. All right, in the next video I'll post the answers to these questions. All right, stay tuned. Bye bye.